Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, so last weekend we have taken the class. Okay, so today we'll start with the properties of the determinants. Correct. So there are total of total we're gonna take eight properties. Sorry, seven properties of the determinant. Okay, with a few examples. So let us start now. Let me put the heading first. Properties of determinant. Okay. So first property one, the value of determinant remains unchanged if the rows and the columns are interchanged. Okay, so that means, and it is denoted by this symbol and called transpose. So let us look at one example. Let D is equals to A1, A2, A3, B1, B2, B3, C1, C2, C3. So that is equals to D dash, which is transpose A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. So this thing you need to remember means its value does not change. Okay. Since the determinant remains unchanged when rows and the columns are interchanged, so it is obvious that any theorem which is true for rows must also be true for the column. Got it? So it was the first property. Here d dash equals to d, so d and d dash are the transpose of each other. Correct? So let's move to the next property. Property number 2. If any two rows yeah or columns of a determinant be interchanged, the determinant is unaltered in numerical value but is changed in sign only. What does it mean? Let's look at with example. Let D is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3, and D dash is A2, B2, C2, A1, B1, C1, A3, B3, and C3. So these two are altered. These two are altered. So d dash is equals to minus d. Okay. So this thing you need to remember. So with this, let's do property number 3 as well. If a determinant has two rows or columns, means identical, then its value is 0. Let d is equals to a1 b1 c1 a1 b1 c1 a2 b2 c2. So here first and second are same, identical. So we can say d is equals to the value of this determinant is 0. The value of this determinant is 0. So copy both the properties, then we'll move to the next one. Okay, so next is property fourth. If all the elements of any row or column we multiplied by same number, then value of that is multiplied by that number, means d is equals to a1 b1 c1 a2 b2 c2, sorry c2 a3 b3 c3, and d dash is equals to ka1 kb1 kc1, then a2 b2 c2 a3 b3 and c3. So d dash is equals to k of d. Next is property fifth. If each element of any row or column can be expressed as a sum of two terms, then the determinant can be expressed as the sum of determinant. Let's look at the example like a1 plus x, b1 plus y, c1 plus z. Here a2, a3, b2, b3, c2, c3. So this can be written as a1, a2, a3, b1, b2, b3, c1, c2, c3 plus x, y, z, a2, b2, c2, a3, b3, c3. So these both are equal. Okay. So you can copy property fourth and the property fifth. Okay. Next, property sixth. The value of a determinant is not altered by adding to the elements of any row or column. The same multiplies of corresponds elements of any other row or column. Means D is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. D dash is A1, MA2, B1 plus MB2, C1 plus MC2. So A2, B2, and C2. Here A3 minus Na2, V3 minus NB2, C3 minus NC2. So then D1 is equals to D dash is equals to D. Okay. But in this property, it should be noted that while applying this property, at least one row or one column must remain unchanged. Okay. Next, property 7th. If delta x and function of a is equals to 0, then x minus a is a factor of delta, that is d is equals to 1 1 1 a b c, okay, a square b square c square. So if we replace a by b, then d is equals to 1 1 1 b b c b square b square and c square, which is equals to 0. So here we can write a minus b is a factor of the d. A minus b is the factor of d. Okay, so let us look at questions. If a b c are pth qth and rth terms of gp, then log of a, log of b, log of c, pqr 111 equals. So solving this, let a be the first term and r be the cr of the gp. So it becomes a is equals to a, capital A is the first term, okay, capital R is the cr of the gp, common issue, p minus 1. Okay, so b is equals to a of r q minus 1, c is equals to a of r r minus of 1. So next, log a is equals to log of a plus p minus 1 log of r. So that is delta is becomes log of a p1 log of a q1 and log of a r1 plus p minus 1 log r, q minus 1 log r minus 1 log r. That is pq r 1 1 1. So 0 plus log of r is p minus 1, p minus 1 and 1. Similarly q minus 1, q minus 1 1, r minus 1, r minus 1 and 1. So by c2 minus c1 it becomes 0. Okay, so the value of this is 0. Correct? So you can copy this problem. Okay, next is the value of determinant 265, 240, 219, 240, 225, this 198, again 219, 198, 181. So solve first, apply C1 minus C2 and C2 minus C3. So we will get determinant is equals to 25, 21, 219, 15, 27, 198, 21, 17, 181. Now C1 minus C2, C3 minus 10 C2, 10 C2. So it will be 4, 21, 9, minus of 12, 27, minus of 72, again 4, 70 and 11. So now we can write 4, 0, 0, 21, 19, minus 4, 9, minus 45 and 2, because we applied the property R2 plus 3R1 and R3 minus R1. Final answer 4 of 180 minus 180, that is 0. This is our answer. This is our final answer. Okay, so you can copy this problem, and we are going to wind up the session here. Next class, we'll start with the multiplication of two determinants, and then we'll move to the symmetric and skew symmetric determinants, and then the applications of determinants. Okay, then the now start with the solved examples. Okay, so this unit is very important. Okay, so you need to learn it properly. First, copy this problem. Okay, so thank you guys. We'll see you in the next lecture.